Hello, in this video we want to solve for a given 5 raised to power a plus 5 raised to power a is equal to 100. To solve this problem, here is what I'm going to do. We have 5 raised to power a plus 5 raised to power a is equal to 100. There are two of exactly the same terms being added together. So we say 2 into 5 raised to power a is equal to 100. Let us divide through by 2 so that we are going to have 50 on the right hand side. That is, we have 5 raised to power a is equal to 50. Now, 50 itself can be expressed as 5 times 10, and 10 as well can be expressed as 5 times 2. This implies that 5 raised to power a is equal to 5 raised to power 2 times 2. In order to put all of the 5s on the same side, I'm going to divide through by 5 raised to power 2 so that we get rid of 5 squared on the right hand side, and we have 5 raised to power a divided by 5 raised to power 2 is equal to 2. Now we can apply the law of indices. Remember, when you have m raised to power, say, x divided by m raised to power y, you can express this as m raised to power x minus y. When you have division, the powers are subtracted. So in this case, we have division. We're going to say 5 raised to power a minus 2 is equal to 2. The next thing we're going to do is to take the logarithm of both sides. So we have log 5 raised to power a minus 2 is equal to log 2. There's a law of logarithm that says when you have the logarithm of, say, m raised to power x, you can express this as x times log m. And then this power a minus 2 becomes a pre-multiplier a minus 2, then times log 5 is equal to log 2. Let's divide through by log 5. That way, this takes care of this, and we have a minus 2 is equal to log 2 divided by log 5. We can make the expression on the right a little more tidier by applying the law of logarithm that says when you have log m, for instance, divided by log x, you can write this simply as log m base x. And that will mean that a minus 2 is equal to log 2 base 5. Now let us solve for a. A minus 2 is equal to log 2 base 5. If we add 2 to both sides, then we have a is equal to log 2 base 5 plus 2. This will be our final answer. Now, to confirm that this final answer is correct, we are going to insert it. Remember, our initial equation is 5 raised to power a plus 5 raised to power a is equal to 100. Now we are going to insert this value, a equal to log 2 base 5 plus 2, into each of these positions, and it should give us 100 on the right hand side. So we say 5 raised to power a is log 2 base 5 plus 2, so we say log 2 base 5 plus 2, then plus 5 raised to power log 2 base 5 plus 2 and this should give us 100. For each term on the left hand side, we're going to apply the law of indices that says when you have m raised to power, this is addition. So we say when x plus y is the power, you can separate the powers into individual bases, m raised to power x times m raised to power y. In this case, our m is 5. Our powers are log 2 and 2 respectively. So we have 5 raised to power log 2 is 5 times 5 raised to power 2. The same applies to the second term. 5 raised to power log 2 base 5 times 5 raised to power 2. And if done correctly, this should give us 100. This is 25. And this is 25 as well. But what about this and this? The expression 5 raised to power log 2 base 5, we are going to resolve it by considering the law of logarithm that says when you have, for instance, p raised to power log m base p, the result is always m because this base and this base are the same. So in this case, the result will be 2. And then we have 2. Remember, this is a multiplication. And then this will be 2 as well. Then times 25. And this should give us 100 if done correctly. So 2 times 25 here is 50. Then plus 2 times 25 here is also 50. And of course, by mere looking at it, 50 plus 50 is 100, which means our solution is correct because the left-hand side is exactly the same thing as the right-hand side. So thank you so much for watching. If you have enjoyed this video, kindly hit the like button, subscribe to my YouTube channel, and I'll see you in my next video.